Okay, thank you very much. Hello, everyone. I'm Eleni. I'm very glad being here with you. Before diving into my topic, a very big thanks to New Source Data and the people behind it, William and Ben, for giving the opportunity to new speakers. And also a big thanks to my mentor, Mark Leifeld, who helped me and guided me throughout the preparation and process. So about the topic today, everything started some months ago when I did a project in the Port of Amsterdam, and I was asked to make a boat animation in Power BI. So that gave me the opportunity to dive into the different spatial data and see all the different map visuals. And I would like to share with you today all this information I gathered back then. So the title is the definite guide to visualize your spatial data with Power BI. So I use the word definitive just to show the full process from data gathering, data visualization, and also data preparation. Okay, so before diving more into details, I would like to introduce myself. I am Eleni Bampalouka. I am originally from Greece. I've been living the last 6 years in the Netherlands. I came in the Netherlands to do my master's. I did my master's in water science and management, and I have also a bachelor in geology. So quite different from the data world, but I made the switch 2 years ago, and I'm really happy for that. I'm currently working for Heineken as a consultant. I joined the company as an external consultant back in February, and then I joined the team internally since June, so quite new. As I said, I am originally from Greece. Now with the COVID-19, I am currently located in Greece since July, and I'm working from home. I think most of us might work from home as well. I'm now living in this tiny little red star on the map. It's 2 hours in the north from Athens. I'm in the middle of the nature, kind of middle of my holidays. And just a small tiny story about this little insect on the right. You might wonder why I put this image. So this little insect has a very interesting story. I found an article about it, very recently. So it lives like a little worm, like a larva, underground for its whole life. So for around 4 to 17 years, depends on the species. And then one nice summerish day, it climbs up a tree and it transforms itself into the way we see, and then it starts singing for just a couple of weeks, and then it dies. So it's a very interesting story because it's always like on the ground, and then it climbs only for some weeks, and then it dies. So yeah, it lives in the south of Europe and also I think in more hot places around the world. So yeah, back to the topic, the definite guide to visualize your spatial data with Power BI. Just to give you an overview about what I'm going to focus. So I would like to start with a broad overview about what is geodata, and then what we define by geodata, spatial data, what do we mean, and then also see the different thematic categories that we use as geodata for different analysis, how we define the topic, and also what are the geodata types. By the word types, I mean mostly the formats and the files that we use. So then I would like to take this broad topic and focus in Power BI and what is happening there. So what are the geodata we use in Power BI? What are the different geometries we can visualize? And also what are the import methods? How we can import data to Power BI, what is different ways, and then how we visualize them. Of course, we cannot talk about geodata without referring to maps. So maps is the means of visualizing geodata. So I would like to show the different map components within Power BI and also the different thematic maps that we have and the different map categories. So every map has its own service and purpose. So we can make categories based their code and how we use them. And at the end, there is a demo. I would like to show how we prepare Geo Data before importing into Power BI, and also demonstrate how some map visuals work. So the map visuals I'm going to focus are ArcGIS for Power BI, MyBox, Azure Map, and Territory Map. So there is a reason why there is a focus on those specific map visuals, but this will come out of our story today. What is geodata? So when we talk about geodata, we are referring to any information that describes a location on Earth. So any type of information like an address, a postal code, a country, all those are geodata. So geodata are interpreted and analyzed by Geographic Information Systems, GIS. So Geographic Information Systems are mostly the software where we import geodata. We create layers, we create maps, we make a lot of types of analysis. So geodata cover 80% of the whole problem analysis. In the beginning, when I saw this, I found it in the documentation of Azure Maps. I thought it is quite exaggerating, let's say. But when I think about myself, the last 3 months, and the projects I've been involved, in 2 out of the 3 of them, I needed to make a nice visualization of spatial data. So sometimes in our projects, we have the spatial flavor, but we don't really take it into account. But it's quite important and can bring our projects to next level. So geodata can be divided, let's say, in 2 main categories. They are the more descriptive ones when we use human readable way to describe them, like an address, a place, a city, a country, and all these categories are also included in Power BI. Or we talk about latitude and longitude, we talk about coordinates. So what is latitude and longitude? We can divide the Earth in 2 different ways. We can divide it horizontally with the equator when we start counting from 0, and every parallel line to the equator is the latitude. Latitude is from -90 to 90 degrees. And also we can divide the Earth vertically, and we can divide it vertically with a line called prime meridian, and this line passes through Greenwich, which is a city in England. And every parallel is called longitude, and then we have from -180 to 180 degrees. But why we are referring to degrees? We are referring to degrees because we talk about an angle. It's the angle that is created between the location we are and the equator or the prime meridian. And then latitude and longitude are constructed. So we can refer to coordinates in 2 different ways. The first one on top is the more descriptive approach. When we have the degrees, we have a minute, and then we have the seconds. Minutes and seconds are the subunits of degrees, and then we have the direction where we are showing. So if we are in latitude, we have either to the north or to the south, and if we are talking about longitude, then we are east and west. In case we don't have the direction, then we have plus and minus. In order to go from one system to the other, to the decimal system, to the more descriptive one, then we need to use a converter. There are online many cases so we can find one and make a transformation. So just to give an example about how are the different decimal degrees, I have an example of a latitude, 32.12345, and here is when we talk about precision. So all the different decimal degrees, they express different precision. So if we have no decimal degrees, then we talk about the level of hundreds of kilometers, then 1 extra is tens of kilometers, and then hundreds of meters, etc. But how precise can we be? We can go up to the 6, then we are at the level of centimeters, and we can go even more, and then we talk about research and survey and how we map tectonic plates or faults. So within Power BI, a level of 3 digits or 4 it's more than enough. So just to point out the projection system, the projection system is very important because the process is done before pointing a pair of coordinates on the map. So the Earth is a sphere. Actually, it's not a real sphere. It's kind of an oval shape. And then in order to point coordinates, we transform it into a flat two-dimensional surface. This is done through mathematical algorithms, conical or cylindrical, and many more. And we have the projection system. Every country has its own projection system, and there is also a global geographic system that we can use to point the coordinates. And here we have the topic of geocoding. Geocoding basically is a translator. We translate human readable address into a pair of coordinates. We don't use geocoding when we just drop out an address. Also the reverse geocoding, where it's the opposite. We take address. So there are many different thematic categories about geodata. I just give here a summarized approach of 5: administrative, socioeconomic, transportation, environmental, and hydrographic. So just to have a full view, there are 2 big categories of geodata. One is cultural. Cultural meaning what is related to human activities, and the other one is physical. Physical, what is related to the Earth. Within the cultural, we have the administrative. So then we talk about boundaries. We talk about cities, administrative levels, states, etc. And then we have socioeconomic. Socioeconomic is when we want to show on a spatial overview what is the distribution of a numeric value. For example, what is the percentage of male, female around a region and a country, or what are the sales of a group of stores belonging to a company, and stuff like that. Then we have transportation. Within transportation, we have the railway network, the road network, and also the real-time traffic. This is actually also a new component within Azure Maps. And then we have the physical. Within the physical, we have environmental. Then we talk about land use, agriculture area or city area or disposal area, and stuff like that. And then we have hydrographic. Hydrographic, as the name says, we talk about hydrographic networks, lakes, rivers, oceans, and the elevation. Elevation is a very big category. It's mostly used as a base for other type of geodata. And yeah, it's a group by itself. So let's see the different files we have of spatial data, the different types. The first one is a vector file. A vector file can be either a point, a polyline, or a polygon. So a vector file is made by vertices and paths. And what is interesting about it is that it's dynamic. Every point is connected to a pair of coordinates. So a polyline is a series of points. Polygons is a group of points creating a circle. Then we have raster files. Raster files is that what is interesting about raster files is that they are every color of the image is associated to a value. We have 2 types of raster files. It can be a gradual change of the color. For example, we have elevation and we go from dark brown to light brown, lower, and then green, even lower, and even blue when we are underwater. And then we have also a district change of color. And then we have areas. We have green place, and that is the agriculture area, and the gray place where is the city area. Then we have databases. Databases are actually containers. We have 3 types of databases mostly, which are the S3 databases, GeoPackages, and also specialized databases. It's a container when we can store both raster and vector files. We use it for versioning, sharing, etc. We have the web files. So as the internet is now an online library, spatial data has adjusted themselves in order to be easily accessed and shared via internet. So they have a specific format, like GeoJSON, web mapping services, DRSS are the most famous ones. And it's a way where we can easily share and store data via internet. Also, the big map companies, they have their cloud warehouse and they use this format of files within it. Then we have multitemporal files. Multitemporal is actually a vector file where it has also a time component. It can be weather data, climate data, or how population changes, for example, demographic trend, etc. Sources of geo data. There are many different websites where we can find geo data on the internet. I just put here some of them, the most famous ones, just to point out that there is not one nice big source we can find, but it depends on the orientation of the company that sets their data free. For example, if we check satellite imagery sources, then we can find mostly raster data. In NASA, we can find both vector and raster data and like that. So let's dive now within the Power BI. So the geodata in Power BI. So from all these big categories, in most cases, we use a geographic information system to make an analysis. But within Power BI, there is a focus in those two thematic categories, administrative, socioeconomic. Mostly, we want to show how numeric value is distributed around the map. So we need to show cities and the boundaries, and show, for example, what are the sales around the country, and check. The differential data types in Power BI, we can visualize, of course, vector files. So we can have points, polylines, and polygons. And since we're talking about vector files, we can have also multitemporal files. So ArcGIS maps for Power BI has its own fields in order to import the time component. But if we combine a map visual with the play axis visual, we can easily show a multitemporal flavor of data, combining both time and geodata. We can visualize raster data, an image. This is also included in Azure Maps. Azure Maps, we can import tile layers. And also we can have, of course, web files. So Power BI is cooperating with some map companies like ArcGIS or MyBox, and there we can access their cloud warehouse and have our files into a web format. The most famous one is GeoJSON, and then import it within Power BI. And also databases. This is not directly related to Power BI, but it can be common that we can find files online, for example, a shape file, and then transform it into a web format and then import it within Power BI. So what type of layers can we create? We have two types of layers within Power BI. We have internal layer or else rendering layer. It's all the data we can import from our dataset. And we can import data from our datasets from two types of fields. One is the location, and the other one is latitude and longitude. And also, we can have external source layers or referencing layers, where we have GeoJSON files, TopoJSON, tile layers, images, not the raster file we mentioned before, and real-time traffic layer, which is a group by itself. What is a TopoJSON? So TopoJSON is an extension of GeoJSON. It's a format that encodes topology, and it contains both geospatial data and attribute data. When we talk about attribute data, we talk about all the values that describe the geometry that we have, its numeric value. And what is interesting about TopoJSON is that it uses arcs, it uses polylines. Let's say. So when we have to neighboring surfaces, the boundary between duplicated for both surfaces. So this is also a slightly, benefit compared to GeoJSON is what makes the topojSON much lighter as a file. And so that's it. I just have here an example on the right, an example of the topojSON. And let's move to GeoJSON. So GeoJSON is an extension of JSON. It can end either to .geojson or .json. It contains both geospatial and attribute data. Also, the projection system can be included within the attribute data, and it's the most popular format that is used by GIS software. This is one type of GeoJSON. We can have many different types of GeoJSON files. Many different. I have seen two. Maybe there's also, more. But this is one of the two. So a tile layer. What is a tile layer? A tile layer is actually a raster file that is dynamic. It is stored in a web browser. We request it by a URL request, and we import it into our map. I should not give this opportunity, but we're not going to dive within this presentation in today. What is nice to point out is that we need really to adjust the format of the file because we're talking about type of image, and we need to set up the boundaries so as this image falls properly on the map. We need to set the coordinates. That is about the geodata in Power BI, and let's dive now into the maps. Power BI maps. So within Power BI, we can have, in order to make a map, we have the base map, and then we have the layers. Within layers, we have either a rendering layer or a referencing layer. The rendering is the internal and referencing is the external. Within the rendering layers, we can create thematic maps. The thematic maps are the ones on the right. It can be a simple dot map. It can be a cluster map when we have groups all the different different dots together. We have the corplet map, which is basically a field map, and we have a heat map. The main difference between a corplet map and the heat map is that in the heat map, we are not interested in the boundaries. We just have an overview of the intensity of the dot without focusing on specific regions. While in corplet map, in field map, we're really interested on what is happening within the region. So within Power BI, we have now 17 map visuals in total. 3 of them are the default visuals. We can see them in the overview. And the rest are custom. And also, just to point out, shape map and edge before being visible. So, the different Power BI map categories. Let's start with a simple bubble map. So this is the map we all know. It's the most common one. It's the dot map that we have within Power BI. Then we have the field map, which is the field map and the heat map. We described the difference before. And then we have the line maps. So the line maps are the ones that we can create routes. It's the route map, the flow map, and the icon map. Within the icon map, we can also import small images in order to show the destination of the route. So we have the hierarchy maps, which are the drill down maps. So the drill down maps, they don't have a pair of coordinates that we can import data. They have only the location field, and within the location field, we can import different administrative levels. For example, country, province, county, and then we create a hierarchy. We have then the globe map, which is the globe map and the globe data bars. So we don't have an overview of the base map, but we have the view of the whole globe atmosphere. And then we have external layer maps, are the maps that allow us to import external data rather than the data set that is imported in Power BI. So here we have image maps where we can create images and import them in Power BI. And we have also geometry maps. When I say geometry, it's mostly a vector file. It's a file that, we create topology. So within the image maps, we have synoptic panel and Visio. For example, in Visio, we can make an image of a classroom, and then connect, import it within Power BI and connect it to our data set. And then we have geometry maps, which is the shape map, ArcGIS, MyBox, Azure map, territory map. So what is interesting is that shape map is using topojson and the rest are using GeoJSON files. So within our demo, we're going to focus on those 4 maps just because they're focusing on the GeoJSON files. They are connected to, a cloud warehouse, let's say, ArcGIS and MyBox, and also territory map, while in Azure map, we can import directly a map within Power BI. So here, just a summary. On the left, we have the data set where we have a pair of coordinates, or we have location, or we can have both. And then we have what external type of source we can import. So most maps, we cannot import any type of topojson or GeoJSON. We can import the topojson in shape map, but the GeoJSON is Azure map, territory map, ArcGIS, and then we can use images in Synopsys panel and Visio. So in the demo, just to give you a quick overview of the data I'm going to use, I have an Excel data set about the hospitals in USA. It's the name type status, if it's open or closed. And then I have different Geo Data, also coordinates, and a numeric value. And then I have a shape file about USA administrative levels on the level of country. So shape file is made by 4 subfiles. We have the DBF file, which is actually the DBF file, which is actually all the attributes that describe the geometry. It's a table basically. And then we have the projection system, which is stored in a different file. And then we have the SHP file, which is the actual shape or geometry. And then we have the SHX file, which is an index file that connects the DBF file with our geometry, with the SHP. In order to import the shape file into a Power BI, we need first to transform it into a GeoJSON. In order to transform it, we can either use all the 4 files or 2 of them, the most important ones, which is the attribute file and the geometry file, DBF, SHP. So in order to transform it, we have a conversion links. I have here 2, MapShaper and OGR to OGR. And the minimal files for making this conversion is DBF and shapefile for MapShaper. And with the minimal files that are required for OGR to OGR are 3, DBF, SHP, and SHX. So just to give a quick overview about the different maps, ArcGIS uses its cloud warehouse, which is ArcGIS Online. This is what is connected to Power BI. We have 3 types of signing in options. One is the standard, but we don't need to sign in. Then we have the online and enterprise. These are similar. We need to have an organizational account in order to access it. In the past, we could have our own private account, but this is not anymore. Actually, it changed during the COVID-19 lockdown that everyone was creating accounts all the time. I was learning ArcGIS, so then they changed how things are structured there. And we have a points capacity based on the signing option. So in the start around 3,000 online enterprises 10,000. Different types of geocoding, geo-enrichment for polygons. What is interesting about ArcGIS is that it offers a very big library from S3. A lot of information are available if we have an organizational account and we can sign in into online, into ArcGIS Online, then we can use all these data that are available. And also we can use as well a combined location column. What does this mean? So within the location field, instead of putting one single attribute, country, province, state, zip code, address altogether. So this is quite contradictory for what we know about the natives within maps, but this is how Power BI and how ArcGIS works. And we do this in order to help geocoding. So MyBox, the main editor of MyBox is MyBox Studio. We can create a free account with an access token. We can create a pay-as-you-go plan that gives us 50,000 free visualizations per month and 50 free gigabytes. It's very generous for a free account. And MyBox works very nice with big data, and it has a very nice editor. We can create 3D maps. It has a very nice response of zoom in, zoom out. Okay, it doesn't have all this library of S3, but it gives other type of capabilities. And then we have Azure Maps. Within Azure Maps, we don't need to sign in. Azure Maps are still under construction, let's say. At the moment, we have only latitude, longitude. We don't have a location field, but it's going to come in the future. It can visualize 5,000 geometry features and reference layers, only the first ones, but not more. So this is also temporary. The geocoding is based on TomTom maps, and we can import tile layers, and we can import also online traffic layers. And then we have territory maps. So territory map is a map that we need a subscription, we need an Azure key. It's a base of Azure Maps. It's an editor actually that has it based on Azure Maps, and then we can also create our own territories. That is what is interesting about territory maps. But let's see now more in detail of how these maps are made. I'm going to just give an overview of the data set. And here is the Geo Data. I have the different shapefiles of USA, the different administrative levels. So 0 is the country, level 1 is the state, and county is the level 2. And then I have also, I just imported this polyline, just to rail in USA. So I'm going first to transform this data. So now I'm in the map shaper, which is the conversion tool. I'm going to select the shape file. I'm going to take all these files that are connected to describe the USA administrative level 2, import them, and here we have the different geometries about the state. What I would like to do is to use the simplify. So simplify is the process that repairs your files. So if the different polygons are far away from each other, it connects them together. And it also gives us the opportunity to diminish the size of the exporting file. From my personal experience, sometimes that I tried to import a GeoJSON within Azure Maps, I was getting an error. And when I was doing the method of simplification of minimizing the size and also using two files of the two subfiles instead of all the four that shapefile is made of, then I was managing to import the file successfully. So here we are. In order to do the simplification, always we click Prevent Shape Removal and we click Apply. We get the bar, and I just put around 80%. So the bar shows us how we can diminish the size of the file we export, and then we export it. We want to export into a GeoJSON. So this is actually the process of converting a shape file into a GeoJSON. Just to show in folder. Okay, I just take it here, copy. I will put it back within our Geo Data, within the GeoJSON paste. Okay, so this is just very quick data preparation, and now we are back within Power BI. Within Power BI, I have imported my data set, and I'm going to start with ArcGIS. So I just click on ArcGIS. Immediately I have the opportunity of going into online or enterprise. The main difference is just my organization, but the capabilities offered are the same. So we have here the location field. I can actually show very quickly the county. Yeah. So yeah, this is geocoding. It didn't look like this before. So this is a geocoding process, and that is why in the location field, if we use a combined column by having both county, state, province, etc., in the specific order, we can help the visualization. So that will just show that if we put in the location field, then we get immediately a polygon within ArcGIS. We don't get a point. So I will open a new tab just to do the quick overview, and then I will just import latitude and longitude. Okay. So very quickly, yeah, also make the status. Here we have the time when we can create a temporal layer, multi-temporal vector layer, and here is the overview of ArcGIS. Here is the editor, just to show that here are the layers. We can go back to symbology, and yeah, just change very quickly the color. Okay, so what is open is blue. We have the different base maps overview. I will choose the black one for a change, and then I will, yeah, so, and then I would like to import now an extra layer. Let's see here. We have here the reference layer where we can import an external layer and GeoJSON. If we go into ArcGIS, then we have an organizational account, then we just jump into this field. This is ArcGIS Online Overview. So this works with credits. It's yeah, we have in the content overview. Yeah. No items yet. Here are the items. We can add an item. If we go to the map is the editor, and gallery is also what is available. Within the gallery, we see also the S3 library. So here I'm just going to import very quickly from the library of GIS of S3 because I don't have an organizational account, and this is how it looks like. Just to put this under. Okay, okay. And this is, yeah, ArcGIS. Okay, let's move on to MyBox. So let's see how MyBox works. So we have MyBox here. And let's put latitude and longitude. So we have latitude and longitude. Okay, we don't see anything until we put the access token. So if we click here, we can open MyBox directly, and then we have mybox.com. Here is the account. I have already an account, but you can very easily make one. Here is the token. I copy it. I go back to Power BI, and I go to visualization settings of MyBox, and I import Power BI, the access token here, and here it is. Just to make it a little similar, just I would like to put the color. So I have an overview. Nice. And so back to the MyBox. So here is the dashboard. The dashboard is the full overview. This is my account. This is the page you go. And here is the access key. And let's jump into the MyBox Studio, which is the main editor of MyBox. I hope you can see my screen. Sorry, but internet is little, yeah. Okay. Let's be a little patient. It's going to load. If not, I'm going to continue with Azure Maps and then come back to MyBox as well. Okay, here we are. So this is MyBox. So we have styles and tile sets. So within tile sets, we can import the layer here. We can create new tile sets. We can select a file. I'm going to use, instead of the polygon, I'm going to use a polyline. So within my Geo Data, I'm going to use the rails of USA and then confirm. It's a lighter version. It's nice to see also a polyline instead of the polygon. I hope it loads because of my internet. Here it's uploading. Okay. Here we have the default tile set, and then we have also the custom tile set. I have already imported it. So in the ones that we made, if we click the three dots, then we see the tile set ID. Just paste it on a notepad. I just use this, yeah, very quickly. This one is uploading. It's okay, it's going to be uploaded. One moment. And now we have created a tile set. We go to make a style. When we make a style, we create a new style. We have here the overview of all the different base maps. So actually, we import a base map and we customize it by importing the tile set. So yeah, we just load the map, we import the layer, and then we have the tile. I cannot really show this at the moment because it's very slow, but I have the style already here. And if we click here, we see the different details. I have a style URL copy, and then we go back to Power BI. So within the visualization settings, if we go to the map style, we have all the different types of map styles. And then if we click custom, then we have a new link pumping up. Loading. Okay, just show you the overview of MyBox then, because now it's loaded. So here is the polylines are imported, and just continue very quickly to Azure Map, and just go to the reference layer, add the file. I'm going to add the file that I just made back. It's transformed through Map Shaper, and we don't see it. It's not visible yet. Now it's visible, and now it needs also time to be loaded within the map. So yeah, when we work with maps in Power BI, it's nice to be a little patient. Let's see. In the meantime, I will start with territory map. So just to give you an overview, here's the overview of the territory map editor. Territory map is based on the Azure map. We have the project and we have a catalog. We can import different vector files. I will just import state. And here we see how the overview is changing. And we have here the file. I will import also the database. I have so the data set that I use so it will be visible. I will open it now, and how we import it, we just copy and paste it. So here, and then we upload, and we see all the different columns and their type. We go next, and here it is imported. So we just imported two layers. One is the global state boundaries, and then the uploaded points. I'm not going to do any visualization change now. just by pointing out on the global state boundaries and by clicking and also clicking more and also, yeah, we can create territories. I'll just make territory, name it territory 1, and then load it. So just to make a polygon here, and then we can import it within Power BI. So there are many different ways of making territories within territory map. This is its main benefit, but through their public library that they provide, and also through our points, we can make our own territories and then load them in Power BI. I have already made here a project just to show you, and I will just import it quickly. So here are the different territories. There are 4. There are my uploaded points and also global states. How I import it now within Power BI, I need to download the file that has the IDs that are connected to my GeoJSON. So in folder, here is the file, copy, and then yeah, have it here in my dataset, paste. And then we need to import it as a real dataset within Power BI. So insert, so yeah, transform, and yeah, 3 minutes I have is enough. Yeah, just import the CSV, Geo Data and data, back to my dataset. I want to import this file, and then you will see how it looks like. We have markup name, territory name, we have the IDs. Those IDs of the territories are also connected to the GeoJSON. We need to import both datasets and GeoJSON for territory maps. Okay, close and apply. Close and apply. And here we are, it's loading. And now I will put the file. We have the name column, and then I'm going to put the name and also aggregated data column. It doesn't matter. It's just, yeah, I calculate column and also additional data columns. So at this point, we're not focused on there. And if we go back on the map settings, we need to import the Azure Maps key. I have here an Azure Maps key. I'm going to import it. And also what we need is the GeoJSON URL. So we did this export, and from this button we export the GeoJSON URL. We use this one for Power BI, the third option, and we download the link. Loading very quickly. Yes. Here it is. Right click, copy link, and then back to Power BI. Yeah, and now it is set. So we see here on the bottom loading map, and then we have our polygons. So this is how it looks like. Back to Azure Map. Yeah, I need to redo Azure Map, but I don't know if I have time. And then we also have the MyBox and ArcGIS. So just to summarize and conclude, all the different map options, they can give a different opportunity. Territory maps, we can create our own territory. MyBox, it has a very strong editor. ArcGIS, they can provide us with their own library. Azure Maps, they have a great zoom in, zoom out, and we are not depending on an external type of warehouse in order to import data. We can do it directly in Power BI. What matters, and this is my personal opinion, is the accessibility. So I would, yeah, I like both MyBox and Azure Maps because they are much more easier available, and all their options are out there. So thanks very much. That's it.